Welcome to the Explainer. Today we are doing something a little bit different. We are completely rethinking how we view wastewater. We're totally scrapping the idea of throwing water away. Instead, we're looking at a future where wastewater isn't waste at all. It's actually a highly profitable, dynamic resource factory just waiting to be unlocked. Okay, let's dive into this. So here is our roadmap for today. We'll start with the linear water crisis, move into the circular water framework, touch on biological wastewater treatment, dive down into advanced membrane filtration, look at disinfection and reclaimed water, and wrap up with facilities for resource recovery. All right, part 1, the linear water crisis. Take a look at this number on the screen, 80%. That is honestly kind of staggering. Globally, 80% of our wastewater is currently not collected or treated properly. And with urban populations rushing towards 70% of the global total in the next few years, our water stress is just growing exponentially. We are quite literally running out of fresh water to waste. And the root of this entire mess? It's this absolutely broken take, make, use, discharge linear model. Think about it. We extract this incredibly precious water from natural streams, we treat it for human consumption, we use it exactly one time, and then we just thoughtlessly dump it right back into nature, usually loaded with untreated pollutants. The stakes of keeping this linear model are incredibly high, and eutrophication is a perfect example of why. See, when we discharge untreated wastewater, stuff that's packed with nitrogen and phosphorus, straight into our rivers and lakes, it triggers these massive, abnormal algae blooms. And these blooms literally suffocate the water body. They completely block the transfer of oxygen from the air, destroying aquatic ecosystems in the process. It's a disaster. Okay, moving on to section 2, the circular water framework. So how do we actually fix this? Well, by completely shifting to a circular economy. We need to prioritize reducing, reusing, recycling, and recovering. By designing hybrid water utilities that eliminate waste and pollution right from the get-go, we can actually capture the true value of water. And ultimately, we can regenerate our natural basin systems instead of just draining them dry. Which brings us to section 3, biological wastewater treatment. Now, at the absolute core of treating wastewater, we've got two distinct biological methods. On one side, there's aerobic digestion. This uses oxygen to break down organic matter. But here's the catch. Continuously pumping all that air can consume up to 50% of a plant's entire energy budget. That's huge. But on the flip side, we have anaerobic digestion, and this is an energy-efficient game changer. It requires absolutely zero oxygen, none, and it actually produces its own power in the form of biogas, like methane. Let's look at one of these anaerobic engines in action, the upflow anaerobic sludge blanket, or UASB reactor. Basically, raw sewage flows upwards through a bed of microscopic organisms, and these tiny little biological workers just eat up the organic pollutants, converting them directly into usable biogas and nutrient-rich sludge. And they do the whole thing without needing any of that continuous energy-draining aeration. All right, section 4, advanced membrane filtration. Now I want you to really think about the sheer scale of what we are filtering out here. We are targeting things as incredibly tiny as DNA, viruses, and dissolved salts. Standard sand filters? Yeah, they just aren't going to cut it anymore. What we can do now with ultrafiltration and microfiltration is truly awe-inspiring. We can physically block microscopic pathogens and solids, making absolutely sure the water is perfectly primed for the final stages. And this is the crucial point. This is how we stop industrial pollution dead in its tracks. By using high-pressure membranes in reverse osmosis and nanofiltration, we physically trap dissolved monovalent ions and bacteria. We are talking about removing up to 99.5% of dissolved constituents. This right here is the core technology behind incredible initiatives like the Zero Brine project. By combining nanofiltration with electrodialysis, we stop heavy industries from dumping highly saline wastewater into rivers. We strip out the bad so we can recover the good. Next up, section 5, disinfection and reclaimed water. Let's just walk through these final layered steps. After primary settling and that intense membrane filtration we just talked about, we still have to disinfect the water so it's totally safe for agriculture, industry, or even indirect drinking water. But rather than relying on toxic chlorine that leaves chemical residues behind, we use targeted UV light to scramble bacterial DNA. Or we use highly reactive ozone gas to literally disintegrate viral cell walls. It finishes the job cleanly. And finally, Section 6, Facilities for Resource Recovery. First things first, we need a complete vocabulary overhaul. We've got to stop calling these locations treatment plants, like right now. Instead, we need to emphatically start calling them resource recovery facilities, because they are no longer just these dirty disposal sites sitting at the end of a pipe. No way. They are dynamic, cutting-edge resource factories. Just look at these interconnected synergies on this water content value map. All those brilliant microtechnologies we just explored, they cascade upwards, creating massive meso and macro-level business models. This means rural agriculture can literally trade for recovered nutrients, while massive urban industries can reliably buy and utilize recovered ultra-pure water. It's a completely interconnected ecosystem. I mean, look at the absolute bounty we are actively extracting right now. We're generating local fertilizers, we're creating our own biogas energy, and honestly, even more amazingly, through the Zero Brine initiative, we are recovering high-purity salts and commercial magnesium hydroxide straight out of places like Polish coal mines and Spanish silica factories. So instead of polluting freshwater rivers with industrial runoff, we are harvesting ultra-pure water and highly valuable industrial materials. Which leaves us with this final, kind of provocative thought to take away. If our water systems are truly circular, if every single drop of water is reclaimed, if every nutrient is harvested, and if every salt crystal is recovered to be sold back to industry, is there really any such thing as waste anymore? It's a total reframing of our relationship with water, and I really hope it inspires you to champion circular systems in your own industries. Thank you so much for joining me on this explainer, and I'll catch you on the next one.